Mr. B. Welcome to our flipped classroom. Today we're going to be talking about linear regression. So be sure that you understand what's going on here to be applied in our lesson tomorrow when we are doing some stuff with the data about the NFL. Should be an interesting one. So this is an image we're going to look at. So the essential of regression is that you have a series of points here, and we want to get a line to fit to the points as best as possible. We're going to be able to use that line to make predictions. So here's your anticipatory set. I'd like you to find the equation of a line with a slope of -2 and a y-intercept at 0, 4, and also find the equation of this line here. Please pause the video, do your calculations, and then return. These should be the answers you get. So a scatter plot is a series of points on a graph. Here's an example. This is temperature versus ice cream sales. You can see as temperature gets hotter, they sell more ice cream. But there's not a perfect line in the data. We would have to get a line that fits it as best as possible, and that's the idea behind linear regression. Eventually, you're going to have to decide if a line is the best choice. On the left, I would fit a line to that. In the middle, it looks a little more like a J-curve, so that might be an exponential regression. We won't go too much into that, but you will have to evaluate whether or not your data is linear or if it's more exponential or quadratic, which would be what you see here on the right. So these are the equations that are used. You're going to be doing your calculations in a graphing calculator, and I will put links on our Google Classroom so that you could find out more about the calculations. You can look into it. You can do the calculations on your own for the purposes of this project. I'm not sure how much time we're going to have to actually go into these calculations. They're somewhat long, as you can see, but an LSRL is a least squares regression line, and that is the line that you're going to get from the graphing calculator. And the calculator uses these equations to get the best fit line. The slope will be A, and B is the y-intercept of that line. And what the computer's doing is it takes the distance between a line and each point. So these points are in the scatter plot. It starts putting lines in there. And what we're doing is minimizing the distance between the points and the line. So on the left, you see there's a small distance that the point is below the line. Then the other point next to it is slightly above the line. And then you have a large gap between the third point and the line where the point is below the line. So that would be a negative residual. The second point would have been a positive residual. The other three would be negative. And so it's just taking the point on the line minus the actual point. That's the residual. And the equation is making that the smallest distance to get the best line. So we're going to do an example. So this is going to be about diastolic and systolic blood pressure. You go to the doctor, they take your blood pressure. There's two numbers, diastolic and systolic. So for example, this first one would be 42 over 128. The next person went to the doctor and got 48 over 130 and so forth. So we have 11 individuals in this table. And again, I want you to slow the video down, use it as many times as you need to understand the process. So we're going to open Desmos.com, your graphing calculator. You'll add this table, enter all the points. You'll type this code and press enter, and a bunch of outputs will display. So I have also included a link in the slideshow to the calculator, and this one, what I've done here is I've already put all the points in, but I want you to go to Desmos and start from scratch. You'll have to click add item, go to table, add a table, and put all the values in. And the points are not showing up because we're at 0 and the smallest number we have is 42. So you need to drag this You're going to zoom out and drag it up until you see the points. Otherwise, we can't see what we're doing. So there's our data, and it looks like we could probably get a line to fit it. So in the next box, you'll type, this is the code you always type to get a linear regression, Y1. And then this is the approximately symbol. It's right next to the 1 on your keyboard. A, that's our slope, x1 plus b. Okay, and then here's our line. That's the best fit line. And what y1 is doing is calling all the y values, x1 is calling all the x values, and then this code fits the best one to it. There's a residual plot you can access. R is called the correlation. We'll talk about that in a minute. And here's the slope of the best fit line. Here's the y-intercept. So our best fit line will be y equals, or is approximately 0. And go to 4 decimal places, 9954x plus 98.5258. And you can see that's exactly the same line that they fit. So let's talk about these other numbers, these other outputs. So you need to be able to interpret them. So you're going to need to copy some more notes down. Correlation refers to the strength of the linear relationship. There's that R value you see. A correlation of 1 is a perfect line with a positive slope. 0 will be a random scatter, and negative 1.0 is a perfect line with a negative slope. The correlation can only be between negative 1 and 1. It can't be bigger, it can't be smaller. So here's some examples of correlation. Start in the middle. When correlation is 0, you have completely random scattered points. There's no obvious line, there's no obvious curve. It's just completely random. Then as we go up, so 1.0, perfect line. You could easily put a line through all those points. 0.9, it gets a little bit further away from a perfect line, but still pretty close. 0.5, we have a positive slope. It's just less of a close to a straight line. Negative 0.5, now it's close to roughly a straight line. You could fit a straight line. It's not exact, but it's got a negative slope. And then negative 0.9, it's much closer to a straight line with a negative slope than 0.5, but it's still not perfect. The coefficient of determination is the other value they report out, r squared. And what it means is the percentage of variability in y that is attributable to the linear relationship between x and y. And so in our example, let me go back to the graph. We got an r squared of 0.7365. That means that 73.65% of the variability in systolic blood pressure is directly attributable to the relationship between diastolic blood pressure and systolic blood pressure. Let me go back here. Degrees of freedom. The degrees of freedom is n-1. We had 11 data points, so we would have a degrees of freedom of 10, 11 minus 1. And this is part of the calculation that you would need to do if you're not using technology. Some technology will report this out. We've already talked a little bit about interpolation and extrapolation, and I will do some more examples in class with you. So again, please review the video as needed. Be sure to take the quiz in Google Classroom. It's a Google Forms to make sure you understand this process, and be ready to apply your knowledge tomorrow in class as we work on a project regarding linear regression about some data that pertains to the NFL and the National Football League. I trust is a sufficiently interesting topic for you guys, and we're going to have a lot of fun with it. So again, thank you for watching. Use the information as much